Welcome back. So there is the KP value here is the governing equation is this one. So G naught is this and G is because why, by the way, G naught is equal to, because KD and the KI are zero in my algorithm. So let me show you. So let me tell you. Uh, so here KP KD. So here KP only is 1 and the rest things KD and KI is in a 0. So that's why I represented in here my two control gains. So my operational amplifier is in a KI controller, I mean KP controller. So I controlling my plant in a K, so that is why the rest control parameters are 0 and KP is equals to 1. So it is only P controller. Look, so in here KD and KI is 0. So the transfer function, the general governing equation with a controller parameter is KP is equals to 1. Thus, therefore, which is only P controller. Look, there is only P proportional controller. So the very important thing you have to define is how many controllers, especially from PID controller, which controller is implemented for this specific function or for this specific plant. The answer is P controller. Look, the rest are 0 here. So only KP is 1 and the rest are 0. So it is a P controller. So again, the feedback of this transfer function is in a M naught is in a this, and finally there is my grid function. So the grid is on here, grid on. So that's why these are grid is vertical and horizontal grid is. So the next thing is in a numerator 2 3, denominator 3 9 8, and denominator which is sensor. So basically sensors are a very powerful function in control algorithm. So in another sense, sensors are a feedback. So which gives or which sends instruction, which sends signal for the controller parameters. That's why there is my gain here. So I'm sorry. So let me take a break. So here H is 3 and the transfer function TP is in a numerator and denominator. So there is my transfer function. The transfer function, the step response of G is hold is on. So KP is 8, and so there is a KP means in a proportional gain. So that gain is the P controller is 8 and the rest are 0. So we'll see the graph effect in here. So this is a graph step response for my exercise in pressed 1. So another thing I would like to show you is which is very important, by the way. You have to know the analysis of this important thing in mathematics. So there are, by the way, the very important thing. You have to know this thing. So especially this point. So in here we have to see in about different points here. So there is by the way the point is this is a peak value. So peak values are what I presented to all of you on my first tutorial. So there is a peak values. This is in the rise. This is a peak point. There is a settling. So the graph starts to settle down to here. So there is a settling time. So there are two styles. Rise point. So rise value, peak value, and settling point. So these are the very important. So the graph is starting from a very small and a smooth growth, and it starts to tilt to the next transition. That is why I call it set. Rise time. So these are rise times, by the way. So let me clarify for you. So there is a rise time here. So rise times are, look, there is a rise time. The graph is coming from down to here, and it starts to the peak point, and then down here, and which starts settling in here. So there is a settling time here. Look, there is a settling point, and which is what I call it a peak point, and there is what I call it a rise time. So the rise time, peak value, and the system settling point. There is a final value, which is the system come to end, and which is finished the value. So there is a final point, the graph, the function, the response are able to manipulate the system and to the settled value. So this is a settled, I mean the final value. There is a rise, I mean the settling point in this second. There is the peak value, and there is what I call it rise time. So that's why those are especially represented in such a way. So my students, there is the very important and the dynamic lesson, especially in mechatronics engineering department. So the very important thing I would like to advise you is just be better, be excellent, especially in modeling. So after modeling, after finding out the transfer function or the governing equation of every model, and finally we have able to introduce our response, our value, our mathematical equation, our dynamic equation, especially in a huge system. There are a mechanical motion and electrical system. So electrical system to mechanical motion. Every system now we use it is the system input is maybe electrical and the output is a mechanical. So mechanical is in a it's a rotation. So let's take in a UAV, animal aerial vehicle. So animal aerial vehicles got a signal, got a power from the different types of servo motors which are implemented in that particular plant, and got power from a battery. So power from a battery, and that propellers that will drive the entire body of that plant, and which is taken to the air. So that is the mechanical and the electrical system combined together. It boom out for the entire world to solve a very commercial and a very popular problem which are tested in our daily life. So the very first advice of me is be excellent in mathematics. So you have to find out the mathematical transfer equation. Then after you use different simulink and the algorithm developing software is the very important software to do this, especially for control and mechatronics, electromechanical engineering is MATLAB. So MATLAB is a mathematics calculation, which is analysis and designing software. So the mechanical system is analyzed with this particular mathematical analysis software. So this is my today's lesson. So until next time, goodbye, bye bye.